Hello students, in our today's lesson we are going to discuss about chemical bonding and intermolecular. We start defining what a chemical bond is. So chemical bonds are the forces that hold atoms together in a molecule or ions in ionic compounds. Why do atoms form chemical bond? Atoms are more stable when they are at a lower energy state and are excited, which means less stable when at higher energy states, which means atoms form chemical bonds to attain lower potential energy state. That means to become more stable. And atoms use their valence electrons to form chemical bonds. So valence electrons are the ones involved in chemical reactions and therefore the ones involved in chemical bonding or in chemical bond formation. Noble gases are very unreactive atoms, or they are the most stable. What do all noble gases have in common? First, they all have 8 valence electrons, or an octet, except helium, which has 2 electrons, because that is the maximum number of electrons that the first energy level can hold. This shows that octet arrangement of valence electrons must result great stability to the noble gases, and hence all other elements tend to have the nearest noble gas configuration. This is what we call the octet rule. So octet rule states that all atoms tend to have 8 electrons in their valence shell to become more and more stable. But how atoms can do this, which means, in other words, how do atoms form chemical bonds? So atoms form chemical bond, or they attain the nearest noble gas electron configuration by gaining electrons, by losing electrons, by sharing electrons, or by delocalizing their electrons. So when one atom loses electron, the other gains electrons. So this is referred to as transferring of electrons. So when atoms do this, they can form 3 different types of chemical bonds. The first type of chemical bond which is formed by transfer of electrons from one atom to another atom, which is called ionic bond. The second type of bond is called a covalent bond, which is formed by sharing of electrons. And third one is metallic bond, which is formed by delocalized electrons. So we'll see this one by one. The first type is ionic bond, which is also called electrovalent bond. Ionic bond is a bond formed by transfer of electron from valence shell of one atom to valence shell of another atom. For example, ionic bond is formed between sodium atom and chlorine atom. Sodium, the atomic number of sodium is 11, so its electron configuration is 281. So to attain the nearest noble gas configuration, that is the configuration of neon, it tends to lose 1 electron. When you consider chlorine, its atomic number is 17. Its electron configuration is 287. So chlorine tends to attain the configuration of argon, which is 288. To attain that, it tends to gain 1 extra electron. So 1 electron is transferred from valence shell of sodium atom to the valence shell of chlorine atom. This time sodium forms a positively charged ion and chlorine forms a negatively charged ion. And there is electrostatic force of attraction between these two oppositely charged ions, one positive and the other negative. So this electrostatic force of attraction between positively charged and negatively charged ions is called ionic bond. Again, let's look at Bohr diagram of oxygen and magnesium to see the formation of ionic bond and ionic compound between magnesium and oxygen. The magnesium has atomic number of, or it has 12 electrons, 2 electrons in the first shell, 8 electrons in the second shell, and 2 electrons in the third shell. So its electron configuration is 282. While oxygen has 2 electrons in its innermost shell and 6 electrons in the outer shell. This shows that magnesium tends to lose magnesium tends to lose 2 electrons while oxygen tends to gain 2 electrons. And magnesium atom loses 2 electrons, it forms magnesium 2+ ion. And when the oxygen atom gains 2 electrons, it forms an oxygen 2- ion, indicating that oxygen has 2 more negative charges and magnesium has 2 more positive charges. So this compound formed is magnesium oxide, and there is electrostatic force of attraction between these oppositely charged ions, which is what we call ionic bond. Ionic bond can also be formed between calcium and chlorine. This time we use the electron dot structure to show the formation of ionic bond and ionic compound instead of Bohr diagram. It is easier than Bohr diagram because it saves time and space, because it doesn't require drawing a diagram. So in electron dot formula, only we represent the valence electrons with dots. Here calcium has 2 valence electrons, so we put 2 dots around the symbol of calcium, and chlorine has 7 valence electrons. We put 7 dots around the symbol of the chlorine. Here calcium, to attain the configuration of argon has atomic number of 18 and calcium has atomic number of 20, or argon has 18 electrons and calcium has 20 electrons. So in order to attain the configuration of argon, calcium tends to lose 2 electrons, but chlorine tends to gain only 1 electron. So one calcium atom cannot become stable by giving 2 electrons to chlorine, because chlorine will not accept these 2 electrons. It needs only 1 electron. So one calcium atom needs 2 chlorine atoms to give one electron to them. So the calcium, when it loses 2 electrons, it becomes 2+, but twice of chlorine atoms each gain 1 electrons. So this is shown clearly in this diagram, which is called the electron dot formula of calcium chloride. So to draw the electron dot formula for calcium chloride, first draw the electron dot or the Lewis structure of calcium atom. You write calcium, the Ca for calcium, and you put 2 dots around the calcium atom. Second, draw the electron dot or the Lewis structure of a chlorine atom. So first you write the symbol of chlorine atom, which is Cl, and put 7 dots, which is equal in number to the number of valence electrons. Then finally draw the electron dot formula for calcium chloride. Calcium has no more dots because it lost its 2 electrons and the 2 chlorine atoms, indicating that calcium give its 2 electrons to 2 chlorine atoms, and each chlorine atoms gained one electrons. This clearly shows the formation of ionic bond as well as ionic compound between calcium and chlorine atoms. Again, let's see the formation of ionic bond using electron dot formula between potassium and fluorine. In ionic bond, electrons are lost or gained, resulting in the formation of ions. For example, in potassium fluoride, potassium has 1 valence electron and fluorine has 7 valence electrons. So potassium loses 1 electron to attain the electron configuration of argon, and fluorine gains 1 electron to attain the electron configuration of neon. So 1 electron is transferred or completely from valence shell of potassium and added to the valence shell of fluorine. That time potassium becomes positive ion and fluorine becomes a negative ion. So potassium ion and fluoride ions. The compound potassium fluoride consists of potassium ions, which are positively charged ions, the fluoride ions, which are the negatively charged ions. So ionic compounds are composed of positively charged and negatively charged ions, and the electrostatic force of attraction between these oppositely charged ions is what we call electrovalent bond or ionic bond. So the ionic bond is the electrostatic force of attraction between the positive ion and the negative ion. So let's summarize the formation of ionic bond. Ionic bond is formed by transfer of electrons. That means the electrons are removed from valence shell of one atom and added to the valence shell of another atom. It is formed between metals and nonmetals because metals have tendency to lose electrons and nonmetals have tendency to gain electrons. So metals form positive ions and nonmetals form negative ions. And the formation of ionic bond is favored by low ionization energy of metals and high electron affinity of non-metals. So the two factors that affect the formation of ionic bond are ionization energy of metals and the electron affinity of non-metals. Finally, we'll discuss about naming ionic compounds. Ionic compounds are not formed only between metals and non-metals. Here are 4 cases. The first case is that ionic bonds formed between metal and non-metallic elements. So at that time, write the name of the metal followed by the name of non-metal ending with IDE. For example, NaCl is an ionic compound. The metal is sodium, so you write sodium. Then the non-metal is chlorine, and its ending is changed into IDE, so it is sodium. It becomes sodium chloride. The other is second case in which the ionic compound is formed between a metal and a negatively charged polyatomic ion. For example, here NaNO3 is an ionic compound in which there is a sodium positive ion and nitrate negative ion. So when you name this compound, you write the name of metal followed by the name of the negatively charged polyatomic ion. So the name for this becomes sodium nitrate. Third case is the name of positively charged polyatomic the ionic compound is formed between positively charged polyatomic ion and a non-metal. This time you write the name of positively charged polyatomic ion followed by the name of a non-metal ending with IDE. Here the polyatomic ion is ammonium ion, the non-metal is chlorine. so its name becomes ammonium chloride. Fourth case, the ionic compound may be formed between positively charged polyatomic ion and negatively charged polyatomic ion. So this case, we name the ionic compound by writing the name of positively charged polyatomic ion followed by the name of negatively charged polyatomic ion. Here, for example, is NH4NO3 is named as ammonium nitrate. More on naming ionic compounds. Here, for example, KClO stands for potassium hypochlorite, KClO2 potassium chloride, KClO3 is potassium chlorate, and KClO4 is potassium dichlorate. Finally, we'll discuss about the general properties of compounds. Let's remind what ionic compounds are. So ionic compound is a chemical compound in which ions are held together in lattice structure by ionic bonds. And ions in ionic compounds are held together by electrostatic force between positively charged ions, which is called electrovalent bond or ionic bond. So ionic compounds are tightly packed together to form ionic crystals. The yellow ones are the positive ions and the blue ones are negative ions. These are tightly or closely packed together to form ionic crystals, and they are held in their position by the strong electrostatic force of attraction between these two opposite charges. Notice that in this crystal, in this ionic crystal, the ions are arranged in a regular pattern. Look, the yellow one is surrounded by blue one, and the blue one is surrounded by yellow one, and these are arranged in a regular pattern. This regular pattern is what we call a crystal lattice. So a strong force of the strong attraction of positive to negative results in the formation of what we call a crystal lattice. Due to this, we call them ionic or crystalline solids. So they are in crystal form, so they are crystalline solids, which means there is no gaseous or liquid ionic compound. All ionic compounds are crystalline solids. They are hard and brittle. They are very hard and firm. This is because each cation and anion, cation is a positive ion and anion is a negative ion, each cation and anion are closely joined together by strong electrostatic force. Thus, it is hard to break down them. Here again, the green color and the yellow color. Here, the green one represents the cations, which are the positively charged ions. The yellow or the orange one represents the negative ions. So each negative ion is surrounded by a positive ion, and each positive ion is surrounded by a negative ion, forming a regular pattern of positive and negative ions called a crystal lattice. So there is a very strong force of attraction between these so many number of oppositely charged ions, so that makes them hard and firm. But if they are hammered, they are brittle, which means they can be easily broken down when hammered. but the structure will break in a characteristic way if a force is applied. This is because when hammered or when external force is applied, the ions of the same charge come together. So these ions repel each other since they are of similar charge, and so they slide over the other. This causes the compound to break easily. So we say they are brittle. Brittle means they can be easily broken when hammered or when we apply any external force. The other, they have high melting point, high boiling point, high density because of strong electrostatic force of attraction between oppositely charged ions. To overcome that strong force of attraction, we need to apply more heat to melt or to boil. And the other is about their conductivity. They are non-conductors of electricity in their solid state. Why is that? This is because their ions are tightly packed with a strong force of attraction between oppositely charged ions, so ions cannot move from one point to another point. However, when they are in water solution or melt, that means when they are dissolved in water, which is called aqueous solution, or when you heat and melt them, they will become in liquid state. In this case, the ions separate or dissociate, and they can move and can carry electricity. That means when they melt or when they are dissolved in water, the ionic bond will break down and the ions will be free to move. If the ions can move freely, they can carry electrical energy or electricity or electric current from one point to another point. So they conduct electricity in molten or liquid state or in aqueous or water solution. And the substances that conduct electricity in their molten state or aqueous solution are said to be electrolytes. So ionic compounds are electrolytes.